You want an example from the top of the page, 23 through 36?
Sure, yeah.
Okay, which one?
26?
Which one?
26?
26?
Yeah.
Okay, very good. 26 cosine theta equals 1 over 9. And that's on page 468. And the question is asking us to find angles. It says, find all angles theta between 0 and 180. So they only want us to determine an angle between 0 and 180. So how do I determine? How do I solve this equation for theta? What do I have to do? Say it again. No.
You inverse cosine?
Exactly. I'm applying inverse cosine to both sides, of course. I need to get rid of cosine. Cosine cannot be eliminated in any other way but just applying the inverse function to both sides. Very good. So then theta equals cosine is inverse of 1 over 9. That's all I need to do. So I go back and put cosine inverse of 1 divided by 9. And that's it. Roughly about 84 degrees. So theta, approximately 84 degrees. Now, we're asked to find angles, all angles in the first and the second, between 0 and 180.
So we know that reference angles.
Right, but cosine has what sign in the second quadrant?
Yeah.
Oh,
So it's not.
so this is it. That is the only answer.
So if it wasn't, you would just find the reference angle from this.
This is the reference angle. It's an angle in the first quadrant. It's also the reference angle.
Right.
Yep, 84 degrees. Is itself and its reference angle. If they had told us to find all solutions in 0 to 2 pi, then I would have determined which other angle. So this is it for the problem. But now I'm going to ask you, let's say they want us to find the solutions between 0 and 2 pi. So here's my angle 84 degrees. Okay. Which other angle on the unit circle will have the same cosine?
No.
Right. So here's what I do. Why? Because it has to have the same piece called cosine. So this will be the other angle. What is its reference angle?
84.
And how do I get that? From 360?
Minus 84.
Exactly. So what will that angle be? So I'm going to call it alpha. 360 minus
276.
276 degrees. But we are only asked to give solutions between 0 and 180. Otherwise, I would have considered the other option because I am told cosine is 1/9. Cosine is a positive number in these two quadrants. So I know for sure I will find two angles whose cosine is 1/9. And you can punch it in your graphing calculator and check. You can punch in cosine 84 and you can punch in cosine 276. What should you get?
Same.
1 over 9. Good. Anything else from this page? Or we go back?
Can we do 1 through 27 through 32?
Yes, we did all of them last time, but let's choose another, please.
Okay, 32.
32.
Yeah, 32.
I'm sorry?
Yeah, 32.
32. Very good. So let's work on 32. Any questions so far, please? Anyone? Okay. 32. 32. Cotangent of sine inverse of 2/3. Where do I start? Where is my starting point?
Draw a triangle.
Always from the inside. Okay, so I'm looking at sine inverse of 2. What is this? What does it equal to? When I apply sine to a number, what is an angle? Very good. So this is nothing else but an angle. I'm going to call it alpha. So alpha equals sine inverse of 2/3. Good. What do you think we have to do to both sides?
Sine.
Of course. So then sine alpha equals?
2/3.
Right. Now I can write the right triangle. Not before having sine alpha. right? So here it is. That's my right triangle. This is an acute angle alpha. What is the opposite?
Uh,
2. What is the hypotenuse? 3. So what is this? The square root of 9 minus 4.
not square root of
Exactly. And now I have anything you want me to do or find, right? But what am I asked to find? Cotangent alpha. How do I determine cotangent alpha?
So it leaves nowhere off.
That's it. What is it?
Square root of
That's it. This is very useful. More for Calc 2 than for Calc 1, but very useful. Good. Next.
I have a question on the,
Yes.
on the other question.
Yes.
Top.
Chris, go ahead.
So if that was inverse cosine, would it just be
So if
zero
you
to pi?
so not so this one inside.
No, the top. Sorry, not that question, but the one on top. That. So if it was inverse cosine, would we just be looking at 0 and pi? Those two quadrants. If it was asking for that. Because I was thinking it was only those two quadrants, but then I got it was not inverse.
I know what you mean. So you're saying if I apply cosine inverse, the answer has to be somewhere between 0 and pi.
Yeah.
Yes, I completely agree.
Okay.
However, when you may be asked, and we will be asked in chapter 7 when we solve trig equations, to find all possible solutions. So this equation, cosine theta equals 1/9, has infinitely many solutions. How come? Here's how come. Do you agree that cosine 84 is 1/9? Then you will agree that cosine 84 plus 360 degrees will have the same cosine.
Yeah.
Then you will also agree that 84 plus 720 will have the same cosine. And then you will also agree that negative 2 pi, right? So 84 minus 2 pi will have the same cosine. 84 minus 4 pi will have the same cosine. So there are infinitely many solutions that end here, and infinitely many solutions that end here. So a trig equation like this in chapter 7 will ask us to find all possible solutions. We will find two solutions, one which is 84 and the other one which is 276, and we will say plus 2 pi k, where k is the number of rotations. Either this way or this way, it doesn't matter. It has infinitely many solutions. How come? Remember the graph of sine and cosine. So here's the graph of sine, and so on and so forth. Here's 84, here's 274, here's so on and so forth. And we have infinitely many, right? And I continue forever. That's why it has this, oh, nobody can see that, sorry. So that's why it will have infinitely many solutions.
So
But two distinct, but infinitely many here and infinitely many here.
So does tangent not have infinitely?
Yes,
Oh, yeah.
yes, yes. You will have infinitely many here. Here's why. So if you want to go back to the graph of tangent, then you will have this, right? So tangent will be this, tangent will be this, and tangent will be this. So if you want tangent theta equals 1, one solution, second, third, infinitely. Because this is 1. 1, 1, 1. So I have pi over 4, but I also have pi over 4 plus pi. I also have pi over 4 plus 2 pi, pi over 4 plus 3 pi, pi over 4 minus pi, pi over 4 minus 2 pi, everywhere. Good. Next question. Are we in the clear with this? How to solve something like this? Both. Right? Yes? Okay. So let's go back to 6.3. We solved each and every type of problem, so I'm hoping that you're going to look at each and every problem that we solved in class. So let's look at anything you want on page 460. I still would like to have some time to review chapter 3.
Can we do
Yes?
like this finding the shaded region ones? I have
Yes.
trouble with that.
Yes. Yes, please choose.
Yeah, 60.
60. Okay, very good. Let's look at 60. 60 on page 460. So, find the area of the shaded region. We are told that the central angle is pi over 3, and the radius is 12. So the only area that is not shaded is this piece right here. This is not shaded. Okay, so let's see what we can, exactly. So let's see what we can do. So I know that the total area, so the total area of the entire circle is pi r squared. So that will be pi multiplied by 12 squared. I'm going to just leave it as 144 pi. Now, if I can determine this, I'm going to call this A1, this area. If I can determine A1 somehow, the shaded area will be minus A1, correct? The entire circle minus that little piece, right? It will give me the entire shaded area, correct? Are you with me? Okay, perfect. So then, what can I do next? I can determine, because I know how, I can determine the area of the triangle. I have 3 formulas for the area of the triangle. And this one is exactly one of them. 2 sides and the angle in between. So I can determine the area of the triangle as 12 times 12 times sine pi over 3 divided by 2. Good. So I have the area of the triangle. So I'm going to simplify. So I get 72 sine pi over 3. Anyone can remind us what is sine pi over 3? Pi over 3 is the bottom angle. How much is it sine? Not 1/2.
32.
Exactly. So it will be 72 times the square root of 3 over 2. The middle angle is the same. So this is basically 36 the square root of 3. Do not touch it. This is good enough. I can also now determine the area of the sector. So what is the area of the sector? So 1/2 radius squared times the angle theta in radians. So this is 1/2 times 12 squared times theta, which is pi divided by 3. So again, I have 144 divided by 2 times 3 times pi. So I'm going to divide and say 72. And 72 is divisible by 3. And I get 24 pi. So, can anyone give us or tell us how to find A1? Exactly. Sector minus? Exactly. So the area of the sector minus the area of the triangle. Area of the sector is 24 pi. Oops, I didn't mean that. 24 pi. minus the area of the triangle, which is 36 the square root of 3. Do not attempt to do anything there. So I'm fine now. I can find the shaded area. Can anyone dictate the shaded area? Shaded area. Exactly. Minus 24 pi. Careful. If I put minus in front of a1, then I have to distribute. I cannot just put minus in front of the first term and forget about the last one.
Oh, plus.
Exactly. So now I'm going to approximate. So 144 minus 24 is clearly 120 pi. 120 times pi. And now minus, I'm sorry, plus 36 the square root of 3. $439.34. 439.34. Whatever measurement unit squared. Any questions? Any questions here? You will be very well prepared for this test if you redo all problems we did in class. Okay, let's go back to chapter 5. I don't think we have any difficulties in chapter 5 because we discussed everything with amplitude, phase shift, only for sine and cosine and only tangent, right? Tangent doesn't have an amplitude. The period is negative pi over 2, pi over 2. I mean, the period is pi. And which functions are even? Cosine is even, and secant is even. Everything else is odd. Okay. Which functions have period pi? Everything else? Correct. What are the numbers in that little box that I created? So 1/2, 1/2, the square root of 3 over 2, square root of 3 over 2, and the middle angle. And we do know the unit circle corners, quote unquote, right? 1, 0, where cosine is 1 and sine is 0. 0, 1, where cosine is 0, sine is 1. Negative 1, 0, where cosine is negative 1 and sine is 0. And finally, good. So which sine is negative 1, cosine is 0. The signs of sine and cosine. The sign of sines, positive and negative. Cosine, positive and negative. Okay. Can I review chapter 3? Yes. Okay, so let's go to chapter 3.
Can we do one more problem?
Yes, of course. Yes.
So can we do an example in
Yes.
39 through 44?
Yes. Please choose. I'm not sure which page you are on.
Okay, it's on page 460.
Yes. Please choose one.
40.
So we are in 460. Let me go back. 460, you want to look at 40? Yes? Okay, 460. 460, problem 40. 40. Yes. So we are asked to write cotangent using only sine. So this is the only one allowed for theta in the second quadrant. So I have to replace cotangent by an expression that has only sine in it and nothing else. Good. So what do we know about cotangent? What is the definition of cotangent? Cosine over sine. This is allowed, this one is not. But I know that there is a relationship between cosine and sine. What is the relationship?
1 plus
Cosine and sine. I'm not asking tangent and secant, and I'm not asking cotangent and cosecant. I'm asking sine and cosine.
Square theta plus cosine theta or cosine
Right.
squared equals 1.
Yes. So sine square theta plus cosine square theta equals 1. So if I want to determine this, I move and take the square root. 1 minus sine square theta over sine theta. I do have only one problem that I have to fix. What is the problem?
plus or minus.
Right. In a specific triangle, in a specific quadrant, cosine cannot be plus or minus. In a specific quadrant, cosine is either plus or minus. Which one is it in the second quadrant?
Negative.
Exactly. So I'll say only negative. So I expressed cotangent as negative the square root of 1 minus sine square theta over sine theta. Is it clear how we determine this from this identity? Right? So I moved sine square to the other side and I took square roots from both sides.
Okay, so since sine's already there, you're only solving for cosine.
I cannot change sine. I'm already told that I can use sine and I can't touch it.
Okay.
Yep. Anything else? Anything else? Can I go back to chapter 3? Yes? Anything else? Shane, are you looking for something? Okay. So let's start with the graphing rational functions, 3.7, okay? How many types of rational functions we know? There are many types, but in this class we can only address 3 types. The first one is what? Same degree over
Same degree over
same degree. Same degree over same degree. Good. What does that have? A horizontal asymptote. Leading coefficient over the leading coefficient.
That's,
Type 1.
type
Good. Type 2 has a horizontal asymptote, type 2. And the horizontal asymptote is always
2 or 0.
y equals 0. Good. And what is the third type?
So it's
Slant asymptote, not horizontal, but slant. Good. So the degree of the top and the degree of the bottom have to be in a specific relationship.
the degree on top plus 1 over the bottom.
Yes. If the degree of the denominator is 3, what should the numerator have? 4. Because the division must be a line. And that's the line that is the quotient, which is the slant asymptote. Perfect. Good. Ready?
So much in this test.
Okay, I'm choosing a problem. Any particular type you want to work on?
yeah, the slant asymptote.
Okay. The only thing that is different with the slant asymptote, you have to use the long division to find the quotient. That's the only thing that is different from the rest.
Yeah,
Okay.
it doesn't matter which one I'm just-
No, that's fine. Let's do 66. That's fine. But that's the only difference.
What page is it?
290. So 66. I have f of x equals x squared plus 2x divided by x minus 1. Good. So what is the first thing I have to do? So the question is asking us to graph. What is the first thing I will have to do here?
So find what it can't be.
The two keywords.
Domain.
Yes, also, but the two keywords, factor and simplify.
So factor the top.
Exactly.
Plus X out.
This is very important. If I had to factor the denominator, I would have done that as well. Perfect. So now, yes, I will start with the domain. What is the domain of this function?
Yeah, X, yeah.
Anything but 1. So negative infinity. Good. What are the x-intercepts?
Looks like
When is the fraction 0?
when X equals 0.
Or?
X equals -2.
Exactly. So we already found the two x-intercepts. I know that since x minus 1 does not disappear with anything from the top, x equals 1 must be, thank you, which makes these sides be infinities, but what I don't know is the sign of the infinity. So I will put 0.9 and then 1.1 in the function. Since with 0.9 and with 1.1, the top will not change. Everything is positive here. With 0.9 or 1.1, the top is positive. With 0.9, the bottom is?
Negative.
So what is the sign of the infinity? Yes. And with 1.1, what is the sign of the infinity? Done. Okay. Can this function be symmetric? It crosses at -2 because there is multiplicity 1 for both x-intercepts. So this is a cross, and this is a cross. So it cannot be symmetric, but I will have to write that f of -x does not equal f of x, and it does not equal -f of x, not symmetric. Okay. So now the final thing that I need to determine is the slant asymptote. So all I have to do is, since the denominator is x minus 1, you can use either one.
We do synthetic.
Very good. So what goes in the box if I use synthetic division? Indeed. What is the first coefficient at the top? Right. The next one. And the last one? Exactly. I copy 1. So then 1 times 1 is, right? I copy 3. And then 1 times 3 is, and I box it in. So then f of x, which is x squared plus 2x over x minus 1, can be written how?
So X
Yes?
minus or plus
Yes?
3 over.
I cannot. I have to have a symbol. You're right. When I write 10 over 3, I write this, but not with polynomials. Exactly. I cannot omit that sign. What is at the top?
X minus 1.
What is the remainder?
Yeah, 3.
Good. Over? Good. So now, what is the slant asymptote?
X plus 3.
Y, not x plus 3, but y equals x plus 3. Good. So is this a line with a positive slope or a negative slope? Right. So then what is the end behavior if it has to follow a line with a positive slope? What should I write here? Exactly. Negative infinity, and here? Positive. And I have to write next to my chart so I don't forget. Y equals x plus 3 slant asymptote. Y equals x plus 3 slant asymptote. Ready? Good. When I graph a function with asymptotes, what do I have to graph first? All asymptotes. This one has a slant, not a horizontal. So I have to graph x equals 1. So I write x equals 1 so I know what this is. And then I have to graph y equals x plus 3. When x is 0, y is 3. When y is 0, x is? Exactly. So I have to graph this. Then I have to write y equals x plus 3 somewhere. After I'm done with this, I will plot the points I have. I only have 2. I have negative 2, 0, which is this point. I have 0, 0, which is this point. And now I'm trying to make sense of the information I see. So let's try to make sense of the information we have in the chart. From approaching the slant asymptote towards negative infinity, the function will increase to 0. It will cross the x-axis at negative 2, 0. It will continue to go up because it comes back, it crosses at the origin, and then it continues towards negative infinity. So let's think one more time. From approaching the slant asymptote, crossing at 2, 0, continuing to go up, coming back down, crossing at the origin, and approaching the vertical asymptote towards negative infinity. So this must be it. From approaching the slant asymptote, crossing, coming to a maximum, coming down to cross again, and going to negative infinity. I have no idea where this is. And I can't in pre-calculus. I have to use the graphing calculator. Now let's look at the other side. This makes absolutely no sense. So there is no function that connects positive infinity to positive infinity. So what has to do? Come to a minimum. Imagine x squared. X squared cannot connect infinity. It comes to a minimum and then goes to infinity. So that's what it is. So on this side, it comes from positive infinity, goes back to positive infinity. I have to extend the vertical asymptote, and there is a minimum somewhere here because I have to determine them and put them in the chart. Okay, so now I'm ready to put everything in the graphing calculator. So in y equals, I have to put what was it? X squared plus 2x. Parentheses for the top. Don't forget x squared plus 2x. Close the parenthesis. Divide by x minus 1. And the other function that I have to put in is, exactly, the calculator will not do it, x plus 3. Now I want to, x plus 3. So now I want to, what is this? X squared plus 2x. No, but no. Look at where my red graph is.
Yeah, well, maybe if you graph it, it'll look right.
Oh, okay, so it didn't, okay. So let's see. Okay, now it should be in the right place. Okay. Yeah, I looked at this, look at this. This is messed up. Okay, I just looked at that and I said, oh, what is happening here? Okay, so it's very clear that there is a maximum, a local maximum between negative 2 and 0. I want to determine it. So I go to second and calc. I'm determining a maximum with 4. I know it's between negative 2 and 0. And press enter. It will give me the maximum. No guess. I don't want to guess. You tell me what it is. It's 0.535 or 0.536. So the maximum, I'll go back to my chart. It's at negative 0.73, and y is 0.536. Okay, now I want to determine the minimum. So I see the vertical asymptote should be here at 1. So I'm going to say second and calc. This time I want a minimum, so I want 3. And I'm going to put 1.2 as my starting point, which is this. I gave you something else here. Let me go back. So I want the minimum, which is 3. So I want the left bound as 1.1. Enter. And I want the maximum, the right bound. If this is 1, 2, 3, 4, I'm going to put 4 because it passes. For sure, it passes the minimum. So I press enter. I don't want to guess. Just give me the number. So the number for the minimum is at x equals 2.7. 2.7, and it's 7.46. So that's how I determine. I have here a local max, and I have here a local min. I know everything about this function now. Absolutely everything. There's no secrets. Okay. What about a graph with a hole in it? How will I know which graph, which rational function has a hole in it? So let me give you an example. Okay. What type is this? Right. What will be the horizontal asymptote? 1. Leading coefficient over the leading coefficient. Excellent. Let's proceed. We don't have to graph it. I just want to discuss it. So what will I have to do right away? Yes. So let's factor the top. And let's factor the denominator. What is it? In the denominator? Good. So I would like you to give me, so you already gave me y equals 1 horizontal asymptote. Very good. Now I would like you to give me the vertical asymptotes.
So -1.
Right. The answer is no, because I will have to simplify. I have to write x not equal 1 and x not equal -1, but then I will simplify. So the simplified form of this is this. So it only has a vertical asymptote for the factor that still stays in the problem.
Would be a whole number.
A whole at -1. Exactly. So what is the vertical asymptote then? X equals 1 only. So x equals -1 will give a whole. But now how do I determine the point? I only have x. I also have to determine y. I plug in -1 in the simplified form. So when x is -1, I have -1 plus 2 over -1 minus 1. The top is 1, the bottom is -2. So the point that is the whole is what? -1, comma, -1/2. Okay, let's go back to polynomials. Remember the zeros. Remember the remainder theorem. How will I show whether a polynomial has an x-intercept at 1, let's say, or 2? So I have a polynomial. I'm dividing it by x plus 2. And I'm only asking you to find the remainder. How will you find the remainder of this division? Very important. Remainder theorem and factor theorem. So how do I find the remainder of such a division? I'm not asking you to find the quotient. I'm only asking you to find the remainder. How do I find the remainder? A P of, exactly, of, careful, P of, exactly. So the remainder is P of -2. Perfect. What if P of -2 is 0? What will you conclude? What is the relationship between P of x and x plus 1?
There is that factor.
Exactly. Excellent. Please remember this is very useful for the next course as well. So if P of -2 is 0, then x plus 2 must be a factor of P of x. Exactly. If the remainder is 0, it must be a factor. Perfect.
Is that a factor theorem?
That it is.
Okay.
That is. Okay, so would you like to graph a polynomial, a particular degree? And then I would like to talk for a minute about quadratic functions. And maybe look at the problem, the word problem. I would like you to review, this is part of O12, review how we graph the quadratic function as well, please. Okay? With the shape, the vertex, the x and y intercepts, right? The axis of symmetry, and the max-min. Okay, so would you like to graph a quadratic? Would you like to look at a word problem? Would you like to graph a polynomial? I still would like to look at a word problem, though.
Still working.
Okay, on page 231, they're all the same. We have nothing to worry about those. Let's say 64. So this is page 231, problem 64. Let's say a ball is thrown across a playing field from a height and of 5 feet above the ground at an angle of 45 degrees and so on and so forth to the horizontal at a speed of 20 feet per second. Everything is included in that function. It can be deduced from physical principles that the path of the ball is this. We are given the function. We are lucky. We don't have to determine anything. So I'm going to write 400 in the denominator, x squared plus x plus 5. Where x is the distance in feet that the ball has traveled horizontally. Find the maximum height attained by the ball. How do I find the maximum height attained by the ball?
Plug it in.
Careful. What type of function is it?
Quadratic.
Right? How do I find the maximum of a quadratic function? The vertex. Very good. I tortured Chris with this in the previous class. So that's why I was expecting him to answer. If not, just kidding. Okay, how do I find the vertex?
HK, but we don't have H, so we have to
B over
Negative b over 2a. Very good. Negative b is 1. 2 times a is this. So minus 64 over 400. Negative and negative, I flip. So I get 400 divided by 64. So if I divide by 8, I get 50. If I divide by 2, I get 25 over 4. But this is the horizontal distance that will give us the maximum. I want now to determine the maximum. How do I find the maximum? If I have x, how do I find y? Of course. Of course. So then y equals negative 32 over 400 multiplied by 25 over 4 squared plus 25 over 4 and plus 5. And I will plug it in the graphing calculator to see the maximum, to find the maximum height. So, in parentheses, negative in front, 32 divided by 400, and multiplied by, I meant parentheses, multiplied by 25 over 4 squared, 25 divided by 4. Everything squared, plus 25 divided by 4, and plus 5. So the maximum height is 8.125 feet. 8.125 feet. Okay. Find the horizontal distance the ball has traveled when it hits the ground. I don't know why they put it in that order, because nobody can find y before you find x. I have no idea why. So what is part B? So this is part A. So maximum height is 8.125 feet. And what is the horizontal distance? (25 over 4 feet). They do that intentionally. I recommend please make it to class on Wednesday, like 4:30.